a new robot gripper technology that will allow robots to lift up to 16,000 times their own weight. An innovation in thermal imaging will help robots see as well in total darkness as they do during the day. Fisker unveiled an electric pickup truck with a range of 547 kilometers. Elon Musk announced that Tesla has almost solved the puzzle of fully autonomous driving. It also created a race car out of broken iPhones and laptops. The U.S. Air Force has ordered 6 Archer Aviation aircabs. NASA demonstrated a robot to explore caves on Mars. All this and much more awaits you in this issue. Let's go! University students from ETH Zurich in Switzerland have created a 4-legged robot that combines the features of a spider and a gecko and is able to move on vertical surfaces using magnetic pads. This allows it to lift loads 10 times its own weight. Meganeko uses special permanent magnet modules that were developed at ETH's Robotics Systems laboratory. Each of these modules contains several smaller magnets capable of being activated and deactivated within a fraction of a second, with a short electrical pulse. Remarkably, the magnets do not require electrical power, and their magnetic force is quite strong. By magnetizing a single foot, a payload capacity of 2.5 times the total weight of the robot can be achieved. At the moment, the current version of Magneko needs operator control via a wireless handheld controller. However, the bot is able to move independently along a predetermined route, changing its position from running on vertical and horizontal ferromagnetic surfaces. Springy rubber footpads help it stay stable on the road. The students plan that future modifications of the robot will be able to automatically avoid obstacles, design its route, and assess the condition of tall structures autonomously. An artist named Liam Hopkins, who lives in London, has created a working race car from discarded and damaged devices such as iPhones, laptops, and televisions. This enthusiast used exclusively electronic trash, utilizing a variety of components to assemble the amazing Formula One car. In her composition, you can find wires, video cameras, motherboards, cases from refrigerators, as well as parts from iPhones, e-cigarettes, and components from laptops and portable consoles. Amusingly, the steering of this unusual car also has its own peculiarity. Instead of a traditional steering wheel, the car is equipped with a modified version of the Nintendo Switch Lite game console. Under the hood is a conventional racing power plant, which allows this car to keep up with the speed of classic Formula One race cars. However, while the technical aspect is impressive, this version of the car looks more simple and flashy than traditional race cars. It is not yet clear whether there will be an opportunity to see this unique car on racetracks. Researchers at Purdue University have developed and patented a method called header text vision that improves machine vision and its ability to perceive its surroundings. Traditional active sensors such as LiDAR, radar, and sonar emit signals and then receive them to gather 3-dimensional information about space. These methods have disadvantages that appear at scale, such as signal interference and human eye hazards. Compared to these methods, video cameras based on sunlight or other light sources have an advantage, but low-light conditions, such as nighttime, fog, or rain, remain a major obstacle. Traditional thermal imaging is a completely passive detection method that collects invisible thermal radiation emanating from all objects in space. But some fundamental problems prevent its use. Today, objects and environments are constantly emitting thermal radiation, resulting in an image of textures called the ghost effect. Thermal images of a person's face show only contours and some differences in temperature. They contain no detail, making them look like ghosts. Header text vision combines thermal physics, infrared imagery, and machine learning. This enables the sensor to recover texture from noisy thermal signals and accurately separates the temperature, emissivity, and texture of all objects in space. Fisker, a company specializing in automobile manufacturing, unveiled a number of new products at an investor event, including a new electric pickup truck called the Alaska. This pickup truck can travel up to 547 kilometers on a single charge and is designed based on the FT31 platform, similar to that of the company's Ocean SUV. The range varies depending on the modification and ranges from 370 to 547 kilometers. But so far, exact information about battery options and cost is not provided. Fisker notes that the Alaska pickup will feature a lightweight design for an electric pickup. It has compact dimensions compared to competitors on the market. There is a retractable surface that changes its length from 37 meters to 28 meters via a button. The vehicle also features a variety of compartments and storage drawers, including a special place for a cowboy hat. A unique feature is the retractable bed on the rear seat, which allows the rear cab window and rear wall to be lowered, creating a platform for sleeping. This can also be used for transporting long items. The price of the new Alaska electric pickup will start at $45,400, but it will drop to $37,900 after accounting for possible incentives. Fisker plans to produce the Alaska in the U.S. at the previously used Lordstown plant. The pickup is expected to be available for purchase to buyers in 2025, which is a relatively quick timeline considering the vehicle was just introduced. Robots are now capable of neatly folding clothes, picking up water droplets, lifting ultra-thin microfibers 16,000 times their weight, and turning the pages of books. The robotics engineers were helped to achieve such versatility by the Japanese art of kirigami, New Atlas reports. This art involves the ability to fold a piece of paper to create a complex three-dimensional shape, such as a house, flower, or animal, by making cuts and holes. Robot gripping strength is usually measured in terms of payload to weight ratio. As the name said, our grippers weigh only 0.4 of a gram and can lift up to 6 kilograms. Elon Musk announced that Tesla is actively working on the last key component to realize fully autonomous driving. In this context, the last phase involves the development of about 300,000 lines of control code in the C++ programming language. Musk expressed this in his blog, emphasizing that this improvement brings Tesla closer to realizing autonomous driving-capable vehicles. The important point is that Tesla plans to rely more on neural networks to control its vehicles in the context of fully autonomous driving, instead of using direct coded instructions. Elon Musk also emphasized that the process of training these neural networks is currently underway. However, existing computational limitations are impacting this process. According to Musk, the company aims to achieve full autonomy by the end of this year. However, he also noted that Tesla has become more cautious in its statements, given regulation and the unacceptability of promises that cannot be kept. Despite the ambitious plans, experts have suggested that moving from the current Level 2 level of autopilot autonomy to Levels 4 and 5, where the car takes full responsibility for driving in most traffic situations, presents significant technical and regulatory challenges. In addition, Level 4 and Level 5 autopilots are not currently approved in any country in the world. NASA has teamed up with engineers from Stanford University to create a small, lightweight robot capable of moving using 4 long extendable arms with grippers at their ends. They intend to use this robot named RichBot for exploring Martian caves. RichBot features a main body and 4 rotating joints positioned at the vertices of a tetrahedron. Its extendable arms can extend directly from each shoulder joint, equipped with grippers at their ends. These grippers will allow the robot to attach to cave walls, and the 4th arm will grasp the next point to pull itself toward it. These sequential actions will enable the robot's movement. Additionally, it's worth noting that RichBot's design is specifically adapted for Mars's lower gravity, smaller size, and weight. These factors will help reduce the overall mission costs, and the optimized exploration modes could increase the likelihood of project success. The U.S. Air Force, in cooperation with Archer Aviation, has awarded several contracts worth up to $142 million. The military has expressed interest in developing all-electric vertical takeoff and landing aircraft that could be used for military applications. Under the contract, the developer will provide up to 6 such electric air vehicles and help train pilots and establish repair and maintenance services. In May of this year, Archer Aviation unveiled a near-final version of an electric aerotaxi prototype called the Midnight. The final version of this prototype, which will be used for certification, is planned for 2024. The military appreciated the speed with which the company developed a working model of the air cab after the announcement, and this confirmed their confidence in the company's potential and its ability to mass-produce the air cab and begin regular flights as early as 2025.